Good afternoon. I'm Spot On Weather meteorologist Matthew Euler. And today I made a special video and I'm going to talk about winter weather wishes. This is a photograph in the Norfolk area after a snowstorm. And, snow events can and do occur in the Hampton Roads area. So let's take a look at the video here that we put together. We're going to show you a little bit about the storm tracks for winter weather events, talk about the average snowfall for the Norfolk, Virginia area, as well as the previous season snowfall data. So let's go ahead and take a look at things. We're going to start off with storm type A. There's going to be multiple storm types I'm going to go through in this presentation, just showing you some of the synoptic setup that will yield snowfall for Southeast Virginia. Right, so the first synoptic setup is storm type A, and the red arrows in these diagrams that follow, that indicates the subtropical jet stream. The the very deep, thick blue arrow represents the axis of the polar front jet stream. The black L's indicate upper level surface pressure features, in this case, an upper level low pressure system. And then the red L indicates surface low pressure systems. And so we're going to go over some of the synoptics that really help develop snow across not only Southeast Virginia in this example in the storm type A, but also you can see it goes down to Northeast North Carolina. So what we have is an upper level low that initially rides the polar front jet stream. And just think of the jet stream as a mechanism that steers storm systems and moves those storm systems, pushes them along. So we have this upper level low that initially is developing over Minnesota. That upper level low then pretty much follows the jet stream winds moving into western parts of North Carolina, eventually moving off the coast there just south of Cape Hatteras. In the meantime, we have very cold air that's coming down in the trough of this jet stream, the upper level trough in the long wave pattern. And so we got plenty of cold air at the surface. We get strong low-level winds developing. We have a surface low-pressure system that's coming up initially from just off the east of Florida, off the coast of Florida, and that's moving up the coast. And that upper-level low, that surface low-pressure significantly intensifies as the upper-level energy, that black L, moves over the top of the surface low-pressure feature. And that really intensifies the storm system, that surface low pressure, the red L there in this diagram, off the mid-Atlantic coast. So great ingredients for snow. If you look at storm type A on the left, shows various events that occur with this type of setup. Anywhere from 1964, 1973, all the way down to 1989. So this is called storm type A. This is what you want if you really want snow across Hampton Roads. Storm type B. Now, with this event, you'll notice some slight changes here. First of all, you have a cold anticyclone or high pressure system that will drift it sets up generally from northern Minnesota. That high pressure system remains fairly strong and it moves over the eastern Great Lakes region. So the clockwise flow around these high pressure systems or anticyclones results in low level cold air flow from the north all the way down into the mid-Atlantic states. Additionally, you'll notice the jet stream, that thicker blue arrow. That's your polar front jet stream and how it is orientated from southern Missouri all the way through Southeast Virginia. You'll have in one scenario, you have an area of low pressure that will tend to develop in the Gulf of Mexico. You got a weak subtropical jet, and you get this area of low pressure that eventually will work its way from the Gulf of Mexico in scenario one to southeast Louisiana. Now, sometimes the area of low pressure will then move northeastward towards eastern Tennessee. But the real good case for snow in Hampton Roads is when the area of low pressure follows a southerly track, and the area of low pressure goes into Jacksonville or just over northern Florida, and then works its way offshore over the western Atlantic, just off of Hatteras. And you'll notice the area of low pressure remains just close enough to the coast to generate the necessary lift to get clouds and precipitation. The black outlined area here indicates a threat area for significant winter precipitation, stretching from Kentucky down into North Carolina and on into Virginia. So this is a great scenario for winter weather once again. And this is also known as a modified Miller-B setup, where you get primary area of high pressure, again, becoming anchored near the eastern Great Lakes. You get strong low-level cold air advection, driving cold air south from eastern Canada directly into the mid-Atlantic. And then at 850 millibars, or 5,000 feet above the ground, there's a redevelopment of an area of low pressure to the south-southeast of the Wakefield forecast area. And the predominant precipitation type in a storm type B, this modified Miller-B, is snow all the way to the coast, a limited mix or rain potential, even at the coast. There's some of the dates and the years for the past events that have exhibited a storm type B or modified Miller-B setup on the left. So you can see anywhere from 1948, we had a storm in March of 1950, March 1960, and just going down the list here, February 17th, 18th, 1979, the February 6th and 7th, 1980 snowstorm across Hampton Roads. So a lot comes into play. We look for the perfect setup when it comes to these winter events for Hampton Roads. Storm type C, moving on to this type of setup. In this type of setup, we have low-level cold air advection from the surface up to about 5,000 feet above the ground, as a primary area of high pressure moves off to eastern New England. So you'll notice a slight difference from a storm type B, where that area of high pressure, that blue H, in this case is over the eastern Great Lakes. With a storm type C, that blue H is now over the coast of Maine. All right, so in general, in scenario one, you get the area of low pressure again that develops in the Gulf of Mexico, and you get that low pressure to move just really close to the coast. In a lot of cases, this results in a cold rain or even a mix of rain and snow for the coastal areas of Hampton Roads. And you get the rain-snow line is generally from Williamsburg back to the northwest. And this snow shield goes all the way up into Massachusetts, Pennsylvania, Maryland, West Virginia, Ohio. So the area of low pressure generally strengthens near the coast as upper trough crosses the mountains. That will give that extra energy to the system at the surface. But again, this is a case where you're getting more of an onshore wind, more of a northeasterly wind, which for Hampton Roads, that generally will result in elevated warm layer, the area above the ground, above 32 degrees Fahrenheit, above freezing, getting thicker and thicker with time. So primary surface low, there you go. This is storm type C. On the left, you have some of the months and dates, years for this type of event, which has occurred. With storm type E, we got generally the polar front jet stream. That blue arrow remains from eastern Nebraska, Iowa, northern Illinois, stretching across New England. You still got the area of high pressure to the north on the cold side of that polar front jet. So you got the Arctic air remaining to the north of that. Then you get a threat area with one or more bands of locally heavy snow. Basically, the lifting occurs on the nose of the subtropical jet stream. And you get areas of low pressure, again, that form the Gulf of Mexico. That area of low pressure then moves it remains more offshore than close to the coast. And that surface low may intensify over time. And so this is another example. You can see where that area is outlined by the black line, where you can get that threat of possible heavy snow in the area. And then at storm type D, there are the dates again, like the rest of the systems. February 1948, we saw this set up. January 15th and 16th, 1957. February 2nd and 3rd, 1978. February 9th and 10th, 1980. And on down to December 6th, all the way down to the bottom is December 6th and 7th, 1995. Moving on now to storm type E. Now, this is a true case of a nor'easter type situation. If you notice, the heaviest access for significant snow, and this is really a really good type of setup for an I-95 heavy snow event, and more of a cold rain along the coast of the Hampton Roads cities. And so you'll see the area of low pressure. It generally moves up along the east coast, all the way up into New England off the coast in the Gulf of Maine. And you get a heavy access of snow to the northwest of the surface low pressure system. You may get a clipper in the polar front jet there up over the upper Midwest heading towards New England as well, which if these areas of low pressure, the energy and the upper levels merges with that surface low, could intensify that low and deepen it even more greatly off in the Gulf of Maine. So this is, again, more of one of those nor'easter type events that extends all the way from the mid-Atlantic I-95 cities all the way north, D.C., so Richmond, D.C., Philly, just on the outskirts of New York City. And there on the left shows the near coast events as well as the offshore events and the various winter weather events, the dates and the years with that. And then for ice, it's another big threat during the winter season is ice. It can be very treacherous for drivers on the roads. You generally see Arctic air mass. Again, see the surface high pressure with ice situation is situated over eastern North Dakota with a clockwise flow around that high pressure system. That Arctic air oozes south and southeast. And then you get the subtropical jet, which is advecting some warm, moist air aloft above the ground on the top or above that really cold air at the surface. And that is a recipe for ice formation. You see a subtropical jet, the red arrow, that is generally indicating the advection of that moisture in from the southwest over the top of colder air at the surface. And so this is what you get with this type of event. You get these series of upper level systems, these disturbances which move northeast along the subtropical jet. And that is some examples there on the upper left of ice events with the months and the years. All right, so now let's turn to the average snowfall each winter for Norfolk, Virginia. Really not a great amount, but I'll tell you what, there's been some really interesting systems in the past winters where you can exceed the seasonal snowfall amount with just one storm. So bottom line here, it only takes one storm, one moderate snow event to possibly eclipse the seasonal normal totals of snow. So in general, in December, Norfolk averages 1.2 inches of snow. As we move into January, the area averages 2.4 inches of snow. And then in February, 2 inches of snow. And only 0.2 of an inch of snow in March. So again, we're not looking at a very large amount of snow each winter on average in the Norfolk, Virginia area. But when we get big events, we get big events. And when I say big events, I'm talking about a 6-inch or greater snowstorm. And it's happened just since 2015. It's happened on 2 occasions. Now I'll go ahead and take a look at some of the snowfall data for Norfolk, Virginia. Now this data is courtesy of the National Weather Service in Wakefield, Virginia. I did want to mention these storm tracks, these graphics are from Wainwright, and I'll get to, Wainwright and Cobb, or Albright and Cobb in a 2004 study. For the Norfolk snowfall data, this is your top 10 list. The snowiest season in the Norfolk area was the 1979-80 season, where 41.9 inches of snow fell. 1935-36, number 2 on the top 10 list at 37.7 inches of snow. I mean, can you imagine over 30 inches of snow in an area that averages about 6 inches a winter? That's saying something. 1892-93 was third on the snowiest season list at 33.3 inches. Working our way all the way down the upper left portion of this graph for seasonal, 1911 and 1912 rounded out the top 10 at 21.3 inches. Now, if you look at the month breakdown, the most snow in the month of December occurred in 1892 at 18.6 inches. I mean, almost 19 inches of snow in the month of December back in the year 1892 in Norfolk. Now, not as far back in the past is the 2010 season, where we saw 17.8 inches of snow in the Norfolk, Virginia area. That's number 2 all time for the most snow in December. So 2004 was a 5.5 inch storm, 5.5 inches of snow for the month of December. In 2004, that was number 9 on the list. So, we can get some pretty significant events. Now, in January, the most snow occurred in the year 1966, where 14.2 inches of snow fell. And then 1955 followed that at 13.8 inches, 1893, 13.7 inches. And then if we go back to 2018 in the month of January, the The Norfolk area got 13.1 inches. It was fourth all time on the list for the snowiest Januaries. So again, not that far back in the past. And then you go down the list a little bit more and you see 2014. 2014 is number 7 on the list for January, one of the most snowier Januaries at 11.5 inches. Moving on to February, most snow, number 1, 1989, where 24.4 inches of snow fell in the year 1989 in the month of February. 1980, that's mostly attributed to the circus blizzard, 18.9 inches. And then on down the line, 1979 was number 6 on the list at 12.7 inches. 2015, there's another 2000, between 2010 and 2020 year, number 7 at 11.5 inches. Moving along now to March. The snowiest season in Norfolk, snowiest March in Norfolk occurred in the year 1914, where 14 inches of snow fell. In 1980, I tell you, 1980 was a heck of a year if you like snow, because number 2 on the list in the month of March in 1980 was when 13.7 inches fell. So between February and March of 1980, those 2 months, you're looking at over 31 inches of snow that fell in just 2 months in the year 1980. So that was a very snowy winter across Norfolk. Moving on now, for the seasonal, the least amount of snow on the other side of the event, the least amount of snow, several years came in with just a trace amount, number 1 on the list. Several years came in at number 2 with just 1/10 of an inch of snow. 2007, 2008 was the third least snowiest winter, 0.2, 2/10 of an inch. 98, 99, number 4 at 0.3, 3/10 of an inch. 1948, 49, 4/10 of an inch. 1989, 90, 5/10 of an inch. And right on down the line. So this is some great data that the National Weather Service puts together. The average snowfall in Norfolk for a season is 5.8 inches. Moving ahead now to all-time record snowfall events. So, and this involves 3 particular areas, Richmond, Virginia, Norfolk, Virginia, and Salisbury, Maryland. The one on the left shows the all-time record snowfall events. And these were some of the biggest snowstorms. I'll focus my attention really on Norfolk, since we're really focused on the Hampton Roads areas. But also, please feel free, if you're from the Richmond area watching or Salisbury, Maryland area, you can also see your rankings there next to the Norfolk area. So number 1 on the Norfolk list for an actual record snowfall event was December 27th and 28th, just after Christmas in the year 1892, when 18.6 inches of snow fell with 1 storm. February 17th through the 19th, 1989, 15.4 inches of snow fell over that period. December 25th and 26th, 2010, snow started falling on Christmas and lasted into the 26th the next morning, and 14.2 inches of snow fell. That is impressive. Number 4 on the list for the all-time record snowfall events for Norfolk, Virginia, 13.7 inches back on March 1st and 2nd, 1980. And then if you work your way down that list, nothing really, well, I will say 10.3 inches. That's on January 3rd and 4th of 2018, so that wasn't too far away, too long ago. Moving on to the image on the right, the graphic on the right, all-time record daily snowfalls for Norfolk, Virginia. Daily snowfall over a 24-hour period, 17.5 inches on December 27th, 1892. 13.4 inches, again, that's at December 26th time period, 2010. 11.8 inches is number 4 on the list, February 6th, 1980. And then working our way down from there. You can take a look at that. I'll go ahead and leave that up for you to really digest the information. All right, so we'll move on to the final slide. Again, I want to definitely give credit to for the storm track graphics, a courtesy of research conducted by Cobb and Albright, 2004 study on mid-Atlantic snowstorms. So all the tracks here, that's courtesy of those 2 gentlemen. All right, so a common theme for winter storms across Hampton Roads, first is the influx of colder Arctic air at the surface from eastern Canada. That's when you need that large, sprawling Arctic high-pressure system to be to the northwest of the area, generally located or anchored over the eastern Great Lakes. A clockwise flow around that Arctic high pressure system will direct much colder air from eastern Canada straight from the north into the area. So we generally like to see a north to northwest wind for snow events in the area, generally from 330 to 350 degrees. That's essential to keep that necessary cold air in place. Additionally, want to mention that a northeast wind, any kind of onshore wind off the water, will generally warm the boundary layer. Now that boundary layer extends from the surface where we live up to about 3,000 feet above the ground. And so what happens with that wind off the water, you get more of a maritime influence. You get generally temperatures warming just enough. It may start as a snow, for example, but then might transition over to a rain, especially in the Virginia Beach area. The further northwest you go, most likely you'll see the snow back towards Williamsburg, northwest. But in general, you get an increase in the elevated warm layer, and that's just simply the area aloft above the ground, which is above 32 degrees Fahrenheit. Eventually, snow will change over to rain in many cases when you get too much of an onshore wind, a northeast wind, east-northeast wind, even a north-northeast wind, 020, 030 degrees, can result in a mix of rain and snow and cut back on snowfall totals drastically for any particular storm event. Additionally, you want to source some moisture. You got to have that source of moisture to provide the amount of liquid in the atmosphere which freezes. An energized subtropical jet stream, that's going to help advect or usher in moist air over the top of colder Arctic air at the surface, while a low-level wind flow will advect moisture in off the Atlantic Ocean. So you're getting upper-level moisture in the form of the subtropical jet from the southwest, bringing that moisture in. And then you're also getting a lot of moisture in from off the Atlantic Ocean. And there's been a lot of case studies where you get these special small-scale, heavier snow bands, which is more known as mesoscale snow bands. It's almost as if the atmosphere is more energized over a smaller area. And so you might see a swath of huge, heavy snow amounts, 6 inches, sometimes 10 inches plus, immediately right along the coast, and then you'll drive to Richmond and there'll be nothing there on the ground. So that's very interesting dynamics. Additionally, you want a water temperature less than 41 degrees Fahrenheit because the water obviously has a modifying influence on the overlying air mass. So you want that water less than 41 degrees Fahrenheit. That'll provide the cold air, enough cold air to keep the precipitation mainly over into a snow. Additionally, the 5,000 foot temperatures, you want those to be negative 5 degrees Celsius or less. 0 to negative 5 degrees Celsius, you could be using a mix of rain and snow with those temperatures. Anything above 0 Celsius, if it's in the positive side of 0 Celsius, is just basically going to be rain. So we look at that. Additionally, the 1,000 to 500 millibar thickness needs to be less than 528 decameters. Now, typically, the rain-snow line east of the Mississippi River is about 540 decameters. But that thickness must be lower, closer to the coast, because of the modifying influence of that water. You want that in order for the precip to remain snow. You need to have that lower thickness, 1,000 to 500 millibar thickness from the surface to about 18,000 feet, that thickness level, to be less than 528 decameters. All right, that wraps things up for today's special video on winter weather. I titled it Winter Weather Wishes. If you're a winter weather fan, you like snow, hopefully this winter we'll see a chance for that. It's a little bit too early to tell. There's a lot of, as my teleconnection videos delve into, there's a lot of variables in play. But one thing I will say is you really have to have a really ideal setup with these pressure systems on the synoptic level to get snowfall in the Hampton Roads areas. But we have seen some pretty big events when we do get snow. So if you're a snow lover, keep your fingers crossed. I know it's a La Nina winter, and I know overall the forecast is for above normal temperatures and below normal precip, warmer and drier winter, but not all La Nina winters are ever exactly alike. There's a lot of variables in play. All right, that wraps things up. Hope we'll follow this up with another video in the not too distant future. Now that we're into the month of November, I would like to maybe delve into past storm cases, past big snow events here in the Hampton Roads cities. So that's all I've got today. Hopefully you guys stay warm. We got a strong Arctic cold front literally outside right now. It's raining as the moisture is converging right ahead of that Arctic frontal boundary, that cold front. And it's going to be a much different air mass tomorrow morning when everybody wakes up in the Hampton Roads cities. It's going to be pretty chilly tomorrow. Wind chill values in the 30s. All right, that wraps things up. Everybody have a great Sunday. This is Spot On Weather. If we're not spot on, we're not doing it right. Take care, everybody, and most importantly, stay healthy.